tried my best to kind of condense this down, but there's a real probability that I might have kind of left out crucial details. So if you have any kind of questions for clarification, and I'm also on jet lag, so there's a non-zero probability that I'll just start speaking gibberish. So just say, Dave, you're speaking gibberish, and I'll try to clarify. So this project is with Craig Fox and Gulden Ulkeman. All of us are psychologists, and really the kind of the impetus for this project was we were looking at the literature in psychology as well as behavioral decision theory, and one thing that struck us was that most of the theories out there treat uncertainty as this unitary construct, but if you look at the kind of philosophy of probability, they conceptualize uncertainty in kind of different ways. And this, I think this quote by Simon Tadeo kind of encapsulates that probabilities can be understood to represent not only chances of outcomes in the physical world, but the strength of convictions that we hold in our minds. So we have these kind of two conceptualizations of probability, and of course these are kind of represented in the two dominant schools of probability theorizing today. You have the Bayesians and the frequentists, with the Bayesians often treating uncertainty as subjective degrees of belief. This is a quote from von Winterfeld and Ward Edwards, that all uncertainties are inherently of the same kind. Probabilities are personal degrees of belief about uncertain outcomes. And then frequentists treat uncertainty as representing this kind of chance process that if you take some experiment and you repeat the experiment over the long run, probabilities are representing the long run frequencies, so that probability is a physical constant belonging to the experiment as a whole and comparable with all of its other physical properties. The theory of probability is only concerned with relations existing between physical quantities of this kind. So we're not interested in the ontological distinction or how to best properly conceptualize uncertainty, but for us as psychologists, what we found interesting is maybe this distinction mirrors a kind of dual set of intuitions that most people have when they think about uncertainty. And for the purposes of this talk, we're going to be calling uncertainties that people represent as events that are kind of in principle knowable, and the uncertainty is really representing subjective degrees of belief. We're going to be calling that epistemic uncertainty. And when people are treating events as uncertain because they're arising from what they view as kind of fundamentally random processes or stochastic processes, we're going to be calling this aleatory uncertainty. And the basic research question that we're going to be looking at is, does how people view these different events, if they view them as epistemic or aleatory, does that have these kind of systematic effects on judgment and choice? And in particular, what I'm going to be focusing on today is how it affects judge probabilities and looking at its implications for judgment accuracy. Okay? So here's a kind of overview of where I'm going to be going today. I'm going to be presenting 3 experiments that are looking at how when people think about uncertainties as either epistemic or aleatory, how that affects judgment extremity. By judgment extremity, I just mean judge probabilities that approach 0 and 1. And then after that, I'm going to be looking at how some of the implications of our findings for different components of judgment accuracy. Okay? So when we started this project, what kind of motivated it was this stylized fact in the literature on overconfidence within the psychology literature is that there's systematic across domain differences in overconfidence. That if you look in the literature, most of the work that's been done on overconfidence tends to use general knowledge items like trivia questions. And there's a practical reason for that. It's because they're immediately verifiable and you can score them. Of course, trivia questions are fundamentally knowable. They're high in epistemic uncertainty. When researchers have looked at other judgment tasks, like if you ask people to predict upcoming geopolitical events or upcoming sporting matches, what they show is that overconfidence is attenuated quite a bit. And in particular is that there's, for the general knowledge questions, is that there's much more clustering around the extreme responses. You're much more likely to get people to say, I'm 100% certain in those types of questions than they are for these ones that involve some degree of chance in it. And so we took this as just a kind of motivating that perhaps this is due to these kind of differences in how people view these different types of uncertainty. So for the first study, what I'm going to show you is just looking at if you take the same event and you get individual differences in the degree to which people view it as epistemic or aleatory, do you see differences in their judge probabilities? Do you see more extreme judge probabilities when they view it as epistemic in nature? So what we did is we took a group of basketball fans. We recruited these through a Qualtrics panel. And we had them make judge probability estimates for 30 basketball matches from the first round of the NCAA tournament. Actually, that's going on right now. So this was conducted literally about 3 years ago to the date. It was incentivized for accuracy. The subjects were incentivized for accuracy. And then afterwards, we had them rate the degree to which they viewed basketball matches as epistemic or aleatory. And I'll show you how we did that. What's that?
Is that a proper scoring?
Yeah, it was in proportion to their Breyer scores. They're quadratic scoring rule. So yeah. So what we did is this is just kind of a first stab at just trying to measure the degree to which people view these events as either epistemic or aleatory. So we created a psychological scale. I know this is a bit loosey-goosey, but at least it's just a first approximation. This is what we did. So we had them, we gave them a series of 10 statements, and we asked them to rate how much they agree or disagree with each of these statements. And so it'd be something like determining which of these two basketball teams will win the game is, and then for 6 of the items, they asked questions that kind of map onto this notion of epistemic uncertainty. So it's in principle knowable. It's something that well-informed people would agree on. It's something that could be better predicted by consulting an expert. Something that becomes more predictable with additional knowledge and skills. And then for the aleatory items, they were asked, it's something that has an element of randomness. It's something that's determined by chance factors. It's something that would play out in different ways on similar occasions. It happens that these two sets kind of break out into separate factors when you do a factor analysis. For the purposes of this paper, they're negatively correlated. And some of our other work, we find that these two factors can be kind of positively correlated as well. And so what I'm going to show you here is we're just taking the sample and we're just taking the upper quartile in terms of the people who rated basketball matches as highly knowable, as highly epistemic, as well as the lower quartile, the ones that viewed it, basketball matches as highly random. And what I'm showing you is for the different matches, I'm showing you the median judge probabilities across the range. So one of the features of the NCAA tournament is that it varies in terms of the degree of parity. So the number 1 team, the number 1 seed team plays the number 16 seed team, and the number 4 seed team plays the number 12, and the number 8 plays the number 9. So you get quite a bit of variability in terms of parity. And so what you're seeing is that for the subjects that view it as high in epistemic uncertainty is that there's just a lot more kind of extremity in the responses, especially as you're getting these strength imbalances. Okay? So the question is, why would epistemic uncertainty, why would you get this effect? What's kind of driving it? And I think it helps to just kind of set up a kind of a generic judgment process. So there's at least 3 steps that are involved. First, people have to kind of establish some kind of hypothesis space. This is usually exogenously set by the experimenter, and then they have to kind of recruit some private covert signal about the kind of evidence for and against the different hypotheses. And then they have to map that private signal onto an explicit judged probability. Okay, and what we think is going on is that in this last step, it requires 2 things. It requires you to integrate both the strength of that signal, so as well as the kind of the degree of weight or diagnosticity of that signal, right? So you get some kind of impression that for and against each of the different hypotheses, and then you have to make an assessment about how predictive that signal is to actual outcomes. And so what we think is that the more that subjects view the underlying uncertainty as epistemic, as they view that private signal, is going to be more diagnostic and more predictive of outcomes. So another way of just saying this is, and I'll kind of unpack this, is that epistemic uncertainty increases sensitivity to evidence strength. So if you have some kind of imbalance in the evidence that you have for and against a hypothesis, how that gets mapped onto a probability judgment is more extreme, the more that you view it as epistemic. And just to pump the intuition, imagine that I tell you that you have 2 players, and player B is 80% as strong as player A, and then I ask you, which of the following is more likely, that player A beats player B in a game of chess, or player A beats player B in a hand of poker? So most people would say that poker has more of an element of randomness, and it's kind of more stochastic and more aleatory than, say, a chess matchup right here. So what I imagine is that most people are going to say is that it's more predictable in the former case than in the latter, right? So you have the same strength and balance, that A is so much stronger than, player A is so much stronger than player B, and you're using that signal and you're more confident in your judgment in the former case because you view it as more predictive of the underlying outcomes, okay? So to make this a bit more formal, we're going to use support theory, and it's a very kind of simple theory. It just says that judge probability is a function of support for a focal hypothesis, normalized over support for both the focal and the alternative hypotheses. And for our purposes, it's just convenient if you convert it to an odds metric like this. And there's a single free parameter in support theory, and it's just basically tells you how this unobservable latent support is related to empirical proxies of support, and it's just through a power function, k. So you just get the scaling constant. And the reason why this is important is that we think this measure k is an index of evidence sensitivity. So just to kind of illustrate this point, what I've done here is I've mapped what I've shown is how judge probability changes as a function of evidence strength at different levels of k. And it looks, you get this kind of logit-like function. So what you see here is that as you're getting increasing evidence strength for, say, hypothesis A over B, is that you're seeing is that probabilities are snapping to 1 up here, and then when you're getting, when there's an imbalance in favor of hypothesis B, is that they're starting to snap to 0, right? So the prediction here is pretty simple. It's just that the more that people view it as epistemic, we should see higher levels of k. And so if we can get an estimate of k, then we can test this, and it's pretty straightforward. We just back it out through just taking the logs of both sides. And so if we just take people's judge probabilities and we convert it to a log odds metric, and then we get some measure of evidence strength for and against each of the hypotheses, and then we take the logs of that ratio, then just through OLS regression, the coefficient that we're going to back out is going to be our measure of evidence sensitivity of k. So that's what we're going to do in the next study. So what we did is we took a variety of different judgment domains that we thought would span the degree to which people view it as epistemic or aleatory. So these things were things like upcoming sporting matches, which of two movies was going to make more money at the box office, as well as kind of general knowledge questions like which of two states was larger. And then for each one, what we did is we had them, in addition to providing a judge probability, is we had them provide some kind of measure of how much evidence strength they had for each of the different targets or each of the different hypotheses. I'll show you how we do this. And then we also again measured the degree to which they viewed each of these judgment domains as epistemic or aleatory. So here's just a kind of what one of the judgment tasks looks like, where they just are told San Francisco 49ers are going to play the Arizona Cardinals. What's the probability that San Francisco 49ers will beat the Cardinals? And they provide a probability estimate. So just point estimates. We didn't do the entire distribution. And this is typically how strength ratings are assessed or elicited. So they're just told, take these two teams. First, choose the football team that you think is the stronger of the two teams, and set that team's strength rating to 100, and then assign the other team a strength rating in proportion to the first team. Right? And subjects seem to have no problem doing this. Okay, so what I'm going to show you here is the mean epistemicness rating for each of those 12 judgment domains, and on the y-axis is that estimate of evidence sensitivity that we back out from their probability judgments, as well as the strength ratings that they provide. And what you can see is that the more that they view it as fundamentally noble, the more that they have, for whatever the kind of imbalance in the strength ratings they have, they affix a more extreme probability judgment to it, the more that they view it as epistemic in nature. And so the correlation is 0.85, and within subjects we get a very strong relationship as well. Okay, so in the last study that I'm going to show you, what we try to do is basically hold everything about the judgment task constant, and then just exogenously can manipulate the degree to which people are going to view the judgment task as epistemic or aleatory. And so this was really inspired by this work in probability matching. When you give people these binary prediction tasks, just really simple, you just say, predict whether the next event is going to be an X or an O, and people, instead of maximizing, they tend to kind of match the underlying probabilities. Is that there's some work out there suggesting that part of this is driven by people's kind of an underlying desire to kind of search for patterns. And the more that people are in pattern detection mode, the more that you get this probability matching. And so what we thought we'd do is kind of, to the extent that you can equate kind of pattern detection with kind of viewing it as fundamentally epistemic, is kind of priming epistemic uncertainty, is that we thought that the different types of instructions that we provided to participants might kind of juice up this underlying tendency. So they didn't know the underlying distribution. We again incentivized them for accuracy, both on this task and on the target judgment task, which I'll show you in a sec. And then we provided feedback after every trial. So we had two conditions. In the pattern detection condition, we told them that the sequences of X's and O's had been set in advance, and your task was to figure out what that pattern is. In the random prediction version, we told them that the order of X's and O's will be randomly generated by a computer program, and your task is to guess which will appear next. Both of these are true because the pattern was randomly generated by a computer, so it's kind of like a half-lie here. And then so for the target task, what we had them do is we gave them a series of probability, or we asked them to judge which of two cities was going to have a higher temperature on a particular date. And the idea here is that if they've just been spending about 20 minutes in this kind of pattern detection mode, is that we're hoping that bleeds over into the subsequent task, and they're kind of more likely to see the event as kind of, or more likely it's going to highlight the aspects of that judgment task that are fundamentally knowable, whereas if they've spent the last 20 minutes kind of in random prediction mode, is that what it's going to highlight is the kind of random aspects of this judgment task right here. So this is the target task. Everything about this is the same for all subjects. Yeah. So what we do is we tell them it's mean squared error, and we kind of basically, say, we give them some examples. So we'd say, for example, if you give a probability judgment of 60%, you should expect to be correct 6 out of 10 times. If you give a probability judgment of 40%, you should expect to be correct 4 out of 10 times. And then basically what we highlight in bold is, in other words, try to do your best to be as accurate as you can. Yeah, I mean, we don't go in that degree of detail about the underlying risk preferences. Yeah. Okay, so what I'm going to show you, there's a couple of different ways in which you can chop up the results. So you can look over trials. The steepness of the slopes are going to be your estimate of k. And so what we see is that in the pattern detection mode, or what we think is priming epistemic uncertainty, is that we see greater sensitivity to evidence strength there. When we do it over items, we see a similar pattern. And then when you look within subjects, this is the CDF for each individual's kind of estimate of their evidence sensitivity, is that we're seeing in all three different versions that when you've kind of primed this epistemic uncertainty, is that you're getting greater sensitivity to evidence strength. Okay, so that's it for the empirics. I just want to talk a little bit about what we think some of the implications are for judgment accuracy. So the basic idea is that you see more extreme judgments the more that you view the underlying task as epistemic in nature. And there's also one of the kind of implications, at least of the model that we have, is that you shouldn't see any differences in the underlying hit rate. So their ability to essentially pick kind of winners and losers in this case. So if they give so the idea, right, is that it's not perturbing the underlying kind of impressions of evidence strength. It's just increasing the probability that they affix to that signal. So it's not changing the sign. So you shouldn't see any kind of differences between high epistemics and low epistemics in terms of their ability to kind of identify which is the correct outcome, and we see that in our data as well. And so what that means is that it's going to imply different kind of types of accuracy in different task conditions. So if you take Breyer scores or quadratic scoring rule, you can break it out or decompose in a couple different ways. And probably the most popular way is to break it out into what's called calibration and resolution. And these are kind of the different components of judgment accuracy. So calibration is basically, do judgments systematically deviate from empirical base rates? And resolution or discrimination is, do the judgments differentiate between probable and improbable outcomes? So over trials, how much information is being contained in a forecast? And just instead of showing you the decomposition, I just thought it'd just be more intuitive just to kind of give you an example. So imagine you have two judges. In this case, you have, so they have to predict, for 5 different tasks, they have to predict how many days it's going to take them to do it and how many days it actually takes them to do it. So you have this forecaster, John, over here. And what you see is that he's fairly well calibrated in that, on average, he's only off by 0.6, but the correlation between from task to task is fairly low. So that is that he's not very good at discriminating when he gives a high probability to a particular, a high number to a particular task versus a low number, right? So here you would say that he's fairly well calibrated, but he's kind of lacking in discrimination. Whereas you have this other judge over here, and you see that he's poorly calibrated and that he's systematically overestimating by 10 days how long each task is going to take him, but the correlation is 1, right? So every time he says it's going to take him 5 extra days, in fact, it takes him 5 extra days. So he's highly kind of discriminating. So the point here is that there are these independent components of judgment accuracy. They're not compensatory. You can be high in both. You can be low in both. And so what does this mean in terms of when you're viewing a task as highly epistemic or highly aleatory? So what we did is, for the last 3 studies I showed you, we actually did the analysis on this. And what you see is that in all 3 studies is that the more, so what I'm doing here is I'm breaking it into quartiles for their degree of rated epistemicness. And what you see in all 3 studies is that you're seeing worse calibration. So this makes sense. People tend to be kind of overconfident, and if you give more extreme judgments under, the more that you view it as epistemic, the more poorly calibrated you're going to be. But because you're not changing the underlying hit rates, but you're kind of stretching out the judgments, you're making fuller use of the probability scale. So what that means is that the more that you view it as epistemic, the more discriminating you're going to be. There's going to be more information contained from judgment to judgment. And we see that in all 3 studies. It also has implications for task environments that lead to systematic overconfidence or systematic underconfidence. So for tasks that tend to elicit systematic overconfidence, what we would expect is that the more that you view the underlying task as epistemic, the more inaccurate you're going to be, right? If people are already overconfident and they're giving more extreme judgments, you're just going to get further and further from the truth. The more that they view it as aleatory, the more regressive, so the more that they're going to be closer to the truth, so they're going to be more accurate if they view it as highly aleatory in task conditions that elicit overconfidence. For task conditions that elicit underconfidence, you would expect the opposite for the opposite reason, is that you're decreasing underconfidence the more that you make those judgments extreme. And so one way in which we can test this is there's this well-known effect called the hard-easy effect, that people tend to be systematically overconfident for difficult test questions, and they tend to be underconfident for easy test questions. So what we can do is, for all 3 of our studies, we can just plot their Breyer scores as a function of how difficult each of the questions was. And so what I'm going to show you here is the estimates from the regression line. So usually Breyer scores are scored, the closer they are to 0, the more accurate they are. Just to make it kind of easier, I just reverse scored it. So higher numbers here mean more accuracy. So what you're seeing is that for difficult questions where people are not getting in them, most people are not getting them correctly, what you're seeing is lower accuracy for subjects that view it as highly epistemic. And that trend is starting to reverse for the easy questions where we see systematic underconfidence. And we see that same pattern in all 3 studies. Okay? So summing up is people intuitively distinguish between these 2 dimensions of uncertainty, that sometimes they view events as fundamentally knowable or epistemic. Sometimes they view them as fundamentally random, or they see them as some mixture of the 2. The more that they view it as fundamentally knowable, it leads to more extreme judgments, holding all else equal. The more that they view it as fundamentally random, the more regressive their probability judgments tend to be. And the greater extremity associated with epistemic uncertainty leads to a decrease in calibration, but improved resolution. So that's it.
I think we have time for people.
Yeah, I'm way ahead. Sorry.
Peter?
If I take aleatory as known probability and epistemic as unknown
Yeah.
probability, then I can say the studying these differences, studying ambiguity attitude.
So we would say that risk is like you know, the 50-50 urn in the Ellsberg setup would be pure aleatory uncertainty, but there's some mixture of epistemic and aleatory uncertainty in the unknown urn, right? So I don't know what the composition of the urn is, as well as if I make a draw from that urn, there's some kind of element as well of aleatory uncertainty as well.
But then my question is, if what you find is different, how that could be related to studying ambiguity attitudes?
So we're actually, with Craig, we're actually looking at this right now. And so we find, Craig has some earlier work that part of what's driving ambiguity aversion is kind of feelings of comparative ignorance, that you feel like you're missing kind of information. And we find that that effect is, what it's underlying that effect is feelings of epistemic uncertainty. So it's only when you think that it's fundamentally knowable and there's missing information that you're getting some of that aversion. And so for example, like one of the studies that we did is, we have 3 different urns and we do all kind of pairwise comparisons. So you have the regular 50-50 urn, you have the regular Ellsberg unknown urn where you make a draw. And then we have another version where you have to guess the color and then we empty out the entire contents. And whichever has a majority red or majority black, you know, if you guess the right color, then you win. So the last urn is pure epistemic uncertainty. And we find that people are more averse to that than the traditional Ellsberg urn, right? Because there's some degree of randomness there, and so I don't kick myself if I can say, well, maybe I got the underlying distribution right, but I just kind of, you know, when I drew a ball, I just kind of got unlucky right there. So some of that, so we think that's part of what's driving ambiguity aversion is that feelings of kind of missing information when you think that it's fundamentally knowable.
The questions about the
Epistemic, yeah, sorry.
I live in a department that has actuaries, and these folks wander around and treat random processes as very real things.
Yeah.
And so it could be that somebody's saying it's a random process, but it's a sufficiently tight random process. So it's not obvious that it would seem colloquially that if somebody says this is a random process, that it means that they're less confident. So if you're telling me what the weather's going to be like in Paris tomorrow, I could maybe give you a reasonably precise
Yeah.
than that. But you know, it's random. There's a randomness to it.
Yeah.
But it's a very tight random distribution. So in some sense, if somebody just says random, it doesn't mean that it doesn't always mean it's got to be very contextual, I would think. So you seem to be interpreting randomness as more diffuse, less confident.
In their probability judgments, but how they, sorry, I'm a little confused by.
Eliciting this using linguistic terms, colloquial terms,
Yeah.
conversational terms,
Yeah.
but interpreting them in a way, and I'm just wondering if there is a translation, literally, from the linguistic terms that you're asking people about, which is fine.
Yeah.
To the technical sense in which randomness implies less confidence. In other words, it's not obvious if you say, is this a random process, that I'm less confident of it than others.
Sure. So if I think the base rate is like, if I think it's a biased coin that it comes up heads 99% of the time,
Well, it could
right?
be that I know it's a deterministic process, but it's such a bloody complicated one that I can't
Sure.
figure it out.
Yeah. Yeah, I think that's right. I think that yeah.
So I have a question about overconfidence that you are
Yeah.
studying there. So which definition of overconfidence do you take? Do you mean
Sure.
that people have a more precise belief, or?
Yeah, so this gets to the citation that Glenn kind of pointed to, the Don Moore. So since we're doing judge probabilities here, it's what's called overplacement. So that they kind of are more, you know, they give When they say they're correct 80% of the time, they're correct 60% of the time. That's kind of what we mean by. But there's different ways. Overconfidence gets used in a bunch of different ways. I'll say, in the way that they recommend, the kind of over distributions is about precision, about how is that people's basically kind of confidence intervals are more narrow than they should be. Don, as well as David Budescu, have basically found that what we've shown here with overplacement also extends to precision, is that the more that you view it as fundamentally noble, the tighter your confidence intervals are.
Because you have the finding that when it's more epistemic,
Yeah.
then people have more extreme views, right?
Yeah.
So,
More extreme beliefs, yeah.
and they differentiate different levels of likelihood to a greater extent.
Yeah.
So this, the second component?
Discrimination,
Yeah.
or resolution, yeah.
Yes, so does that also mean that when it's more epistemic, people are more overconfident in the sense of over-precision?
They should be, I believe, yeah. Yeah.
More questions?
Do you have any sort of psychological intuition for that greater extremity in the epistemic case? Is that I'm trying to get a
So we were saying is that you have some underlying impression of, for each of the hypotheses, right? And let's say there's some kind of imbalance. Your willingness to kind of attach that to a more extreme judgment, the more kind of one way to kind of think about it is the confidence that you have in the signal that you're getting under epistemic uncertainty. You think it's just more diagnostic, right? Because you're not really appreciating. You think, hey, if you think it's fundamentally random, you might say, well, I think that this team is stronger than this other team, but who knows? It could play out in different ways, and so you end up hedging it as a result, right? Does that answer your question or no?
Could it be a social component attached to it? Like, for example, like they know it's fundamentally or socially unpleasant to not know events which in principle know, right?
Yes.
So, and the things which are aleatory or random, right?
Yeah.
And everyone knows that they're random, it's okay for me not to know them. So could it be, the social pressure sort of to guide me into being overconfident? So
Could be. I mean, it could. I mean, we did these online. We incentivize. So I mean, I think we're trying to kind of eliminate some of these demand effects, if you want to call them that. But I think you're right that it does seem more appropriate to kind of. It seems more foolish maybe to give extreme kind of probability judgments if you think it's, fundamentally random.
to appear knowable, right? Or knowledgeable.
Yeah.
So that's kind of
Mm-hmm. Yeah.
Helps I miss the answer to this question. How many questions did you pose to the subjects, and what proportion of them were incentivized? And have you tested the hypothesis that we're answering random, which is what I would do on your experiment?
For which study? So in the first study, we had them do 30 probability judgments. In the second one, we had them do 12 probability judgments. The third one was the most involved because they did, the binary prediction task was like 170 trials, and then it was an additional 28 trials after that. So. But if it was randomness, then you wouldn't be getting a difference across conditions, right?
Well, assume a situation in which you use a random device
Yeah.
to elicit subjective probabilities, and in such case you are using risk and
Yeah.
a random device. Would you speculate that you will have such extremeness regarding epistemic?
Can you give me an example of what you're thinking of?
Well, it's like in the Anscombe-Aumann setup in which you come up with matching probabilities, namely in choice-based. You have
Sure.
event and then conditional on a specific, an event that gives birth to an outcome or nothing. And then on the other side you have
Yeah.
a lottery, and then you equate the two
Sure.
things, and then you come up with it. In such a case, you are using random
Randomization.
to determine subjective probability. Would you speculate that you would have similar results?
But you're using that as like a measurement tool. It's not about the kind of the underlying, right? So in all these cases, we're having them make some judgment about some kind of event, right? And it's their attribution about the event. But maybe I'm missing something here. You think that, so you're asking them about their beliefs, and you're having them do some kind of like a certainty equivalent or something like that. And you think just the fact that you're telling them, hey, we're gonna randomly kind of choose, list out all the different prices, and we're gonna kind of randomly pick one of those. So you think that might lead to kind of shrinkage because you're using chance events? Yeah, I mean, maybe, I'm not sure. Yeah.
Thank you.
Thanks.